Hello dear students, welcome back to my YouTube channel. So am I audible and visible to all of you? Hello beta. Okay, so you have just completed the homework and your answer is 20, right? Mm-hmm. Yes, so I'm audible. Okay. Okay, we can do one thing now. As you know that I am giving the homework, right? And next day we are discussing firstly the homework, then we are starting the class. So we will just continue the same sort of uh, way of dealing with these classes. So let us discuss the previous homework question, then we can discuss further topics. Okay. Okay. So where is okay. So this one NCERT 3.5 includes both symmetry and KCL. Okay. Now what look better. I have given multiple ways in the class, right? I have given multiple ways. Hello Hasna beta. Yesterday I guess you are not present, na? We talk about you that you are not present in the class, my regular students, right? Yeah, today we are discussing weight student bridge, balanced, unbalanced. Then we will be dealing about cells, internal resistance, graphs. Okay, all about these things. Don't miss today's class. Today's class is great. It has a great importance. Okay, no, I am talking about you are present. No, yesterday you were present, but I am talking about the Hasina, right? One more student from the southern region. Okay, she's a very good student. So basically I have given you multiple ways. Okay, so by seeing the circuit you can get your R equivalent. By symmetry methods, folding is also the symmetry method, right? By these types of methods, so I am giving these methods, so at the end you need to apply only one. Look, if you are seeing the circuit and if you are thinking, no, I can use the KCL and I will get my answer in a shortcut way, you need to use KCL, or you need to use point potential method or symmetry method. Okay. So now this one is your homework. Okay. So how to deal with it? Look now. If the potential of this one is zero, okay, zero. Look, in a wire, in a conducting wire, I told you in previous classes there is no potential drop. So same potential will be throughout this wire. Okay. So that means potential of this particular one will be zero. So the potential of this big one will be plus 20 volt. In the same case, the potential of this one will be zero. Potential of this big one will be plus 40 volts. Done. And potential of this one will be X. I need to get this X. But yesterday I told you, na, you are not enough mature, right? Every time you will get demotivated by some silly things. Okay. But you need to think about your aim then. You need to think about your family dreams. Okay. That will give you the boost for your preparation. Okay. If you are very loyal towards your family, study, time, then automatically it will give you some sort of motivation, right? Look, I am an external sort of agent in your life. My role towards your aim is only 5 to 10%. 90% role is yours only. You need to think about yourself. Where you want to see yourself in next 5 years. That will give you the some sort of boost to your preparation, right? Look now. Okay. So how to deal with? So if we are using KCL here, what will happen? Sir, I will use the current due to 2 ohm resistor plus current due to 1 ohm resistor plus current due to 2 ohm resistor equals to 0. This particular statement is from KCL. Okay. I told you in the previous class that we need to think about that X is at lowest potential. Assume. We need to assume, no? Assume. We need to take an assumption X is smallest. Okay, now what is current? Is it potential drop? It is 20 minus X divided by 2 plus, then we have 40 minus X divided by 2, this one, na? Plus, then we have this one. State is how much? 0 minus X divided by 1 equals to 0. I will take 2, it came out to be 40 minus 2X plus 80 minus 2X whole divided by 4 minus X equals to 0. So I can write it equals to 80 plus 40, 120 minus 4x equals to 0. I guess 120 minus 8x equals to 0. X came out to be 120 by 8. Okay. Is it 120 by 8? Am I correct? Am I correct? No? Simple calculation. No rocket science. Simple calculation. Yes, it is 120 by 8. So I guess 120 by 8 came out to be 15 volt. 8 for the 40. Yes, 15 volt. That indicated the potential of this one is how much? Sir, it came out to be 15 volt. Now we will get the value of 2 ohm resistor. How I can get it now? Look. Okay, look better. So what I can write, current through 2 ohm, it came out to be 20 minus X divided by 2. So 20 is 20, X is 15 by 2. 20 minus 15 is 5 by 2. 5 by 2 is 2.5 ampere. Look, it came out to be positive. Now, what we need to get from here, now, if it is positive, it indicates that the direction that we are taking, that is correct. We have taken 20 minus X, that current will flow from 20 to X. So if I need to show here the direction of current, so the current will be like this. It will be 2.5 ampere. Correct. Current will flow from 20 to X. It is correct. Now second one. Now second one is a current through 1 ohm, right? Current through 1 ohm. And it is equals to 0 minus X. X is how much? 15 by 2. It came out to be minus 15 by 2. I guess it is minus 2, so 14, 5, 10, 7.5 ampere. Is it minus 7.5 ampere? Huh? No, it is not. Why? Because here we have only one. Okay, it is one only. Done. So here it is what? Sir, it is only one. So I need to write 1. So my answer came out to be minus 15 ampere. So look, we have taken 0 minus 15. 0 minus 15 simply indicates that we have taken an idea that my current will flow from 0 to 15. 0 to 15. But it came out to be negative. Okay, negative 15. Negative 15 means yes, magnitude is correct, but its direction is wrong. So this is not my direction. Current will flow like this. Current will flow like this. So my current is 15 ampere. I don't need to now what? Talk about this one. If look, current, this is 2.5 ampere and this is 15. That means how much current should enter from this particular end? 12.5. Without solving, na, I know the KCL. So there 12.5 should came from this one 2.5. So 15 is leaving. Summation of current equals to the outgoing current. I will prove it by the equation also. Look now. Third one is what? Third one is current through second 2 ohm resistor. It is 40 minus x. What is x? X is 15 by 2. 15 055 25 by 2, it will be 12.5 ampere. And it is positive. So yes, its direction is correct. It is what? It is correct, right? Yes, 12.5. This is how we need to get our answer. Easy, right? Easy or super easy? Is this easy or super easy? Huh? Easy. Okay. Now what we can do now? I guess we are done with these things now. Let us start now. 2 point. Okay, 2 points. Now we have Wheatstone bridge. Okay. First of all, sir, what is Wheatstone bridge? If we are talking about Wheatstone bridge, but what is Wheatstone bridge? Okay, and why we are studying it? Okay, what is Wheatstone bridge and why we are studying it? Any answer from your end? As you have studied it, na? I guess in all the institutions, up to the fourth chapter is completed, na? The magnetism. So you might have some idea regarding what is Wheatstone bridge and why we are studying it. What is the usage of it? Okay, look, when we are talking about any circuit, so we are majorly interested in calculating the current and in calculating the resistance part. Okay, when we are discussing in from previous three classes, so we are discussing about how to find potential, how to find resistance, how to find current. So to calculate these things, we studied many particular cases: point potential method, KCL, KVL, symmetry. So these things we studied. Okay. So one more type of circuit study by which we will get our answer in a very fast way, and that is Wheatstone bridge. That is Wheatstone bridge. Now, what Wheatstone bridge is all about? So, Wheatstone bridge is a connection of 5 resistors. Okay, how many resistors we are having here? 5 resistors. It is a combination of 5 resistors. Wheatstone bridge is a combination of 5 resistors. And no 2 resistors. I will write here. No 2 resistors. No 2 resistors are either in parallel or series. So it is a combination of 5 resistors, and no 2 resistors are in parallel or in series. So this sort of combination of circuit known Wheatstone bridge. Now how it looks? The simplest way to represent it would be like this. At the end, I will be giving you a shortcut also now, because in your examination you need some short tricks. R1, R2, R3, R4, R5. So this setup is known as what? It known as Wheatstone bridge. This setup is known as Wheatstone bridge. So in Wheatstone bridge, we need to study two things. First one is very famous, that is balanced Wheatstone bridge. Balanced wheat, WSB is short form of Wheatstone bridge. Second one is unbalanced. Wheatstone bridge. So we will talk about one by one. Firstly, we will talk about the balanced Wheatstone bridge, then how to do numericals based on this one, then we will do unbalanced Wheatstone bridge. Okay, I am going from the basics, and if you find any difficulty, you can just ping the comment. Okay. Okay. Look now. So first case that we will study. First case is what? Balanced. So I will write if. So I will write like look now. First one, if no current. If no current flows through fifth resistor. So we called it balanced Wheatstone bridge. Okay. So if there is no flow of current through R5, I will make one more time it, right? So it will look like this now. Look. I hope it is visible to you. This one is R1, R2, R3, R4, and R5. If we are stating that no current should flow from R5, so this particular thing known as balanced Wheatstone bridge. So could you just tell me why there shouldn't be any flow of current through R5? I guess this only happens if the potential drop across this would be same. If the potential difference. Look, if current flows, that simply indicates there is a potential difference. If no current flow, no potential difference or potential same. If potential of this point is X, so it simply indicates potential of this phase should be also X. Why? Because current through this one is 0. Very easy now. Look now. Suppose current I flows from this battery, and as you know that if I current is leaving, I should be into battery. Now this current will go divided. It will divide in two phases. Here I1, here I2. I1 will flow same here I1. Same current I1 will go through R2. Same here I1. Same here I1. Okay. Same here I2. Same I2. Here I2. Here I2. It will leave here I, which is equals to I1 plus I2. I1 plus I2. Done? Okay. Now, we will write the equation. We will write now equation. Sir, which equation we will write? Look now. What is potential of this one? Sir, potential here will be V. this one. And potential here is 0, let us suppose. So I guess the potential here will be 0 also. That means potential here is 0. Potential here is 0. Here potential is x. Here potential is x. Potential here is x. Here potential is v. Here potential is v. And here potential is x. Now we know that v is or delta v equals to I into r. We know this thing now from Ohm's law. So what is delta v? Can I write for this one? Sir, is it v minus x? V minus x equals to I. What is I? Sir, I is I1 into r. What is r? R is r1. Clear? Now, if I need write for this one, I guess this one also I will write. Sir, v minus x equals to, is it I to r3? So therefore, I will write, sir, I1 r1 equals to I2 r3. Clear? In the same way, I need to write for this one. So it came out to be, sir, it will be equals to x minus 0 equals to I. What is I? I guess I is I1 also. No? It is I1 into R2. In the same way, for this one, I can write it as a x minus 0 equals to I2 R4. So I will merge these two. So I will write I1 R2 equals to I2 R4. Done? Now divide. If it is first equation, this one is second equation. Divide first by second. Now I will write it as I1 R1 divided by I1 R2 equals to I2 R3 divided by I2 R4. So you can see here I1 cancel out, I2 cancel out. Okay. So therefore R1 by R2 equals to R3 by R4. So you can also write here proof of Wheatstone bridge. This one is also known as proof of Wheatstone bridge. How R1 by R2 equals to R3 by R4. If let us suppose in the question it is given us it is a Wheatstone bridge. If in our question it is stated that sir, it is a Wheatstone bridge, so it should be clearly in our mind that it should be R1 by R2 equals to R3 by R4. Done? Now how to find the R equivalent of this one? How to find? I guess if I need to find the R equivalent, now look now. How to get it? So I need to rearrange the whole thing. So I can write it like this now. Okay. Now it is easy now. V R1 R2 R3 R4. I can make it like this now. Look now. How, sir? These are in series, so I can write it like this. Look. This one is R1 plus R2. And this one is R3 plus R4. So my R equivalent will be equals to R1 plus R2 multiplied by R3 plus R4 whole divided by R1 plus R2 plus R3 plus R4. So this is how we can find our R equivalent of our Wheatstone bridge. This one. Easy, tough or super easy? It is easy, Tough or super easy? Huh? Am I lagging? One second, one second, one second. No. Easy, no? Okay. Okay. So let us do now numericals so that we will find where we need to and how we can get our answers, right? Easy, no? Look better. Look now. Okay. First question based on Wheatstone bridge. First one. If this one is 50 ohm, 10 ohm, 3 ohm, 25 ohm, and 5 ohm. Done? So look, I guess this one is R1, R2, R3, R4. So what will be R1 by R2? Sir, R1 is 50, R2 is 10. My answer is 5. Done. So what is R3 by R4? R3 is 25, R4 is 5. 5 1 is 5, 5 5 25, it is 5. So therefore, you can state that sir R1 by R2 is equals to R3 by R4. So this is a condition of balanced. So you can write balanced Wheatstone bridge. You can write balanced Wheatstone bridge. There is no usage of this one now. Okay. So how to get my answer now? It's simple. So what will be R equivalent now? Okay. I guess it was R1 plus R2, then R3 plus R4 whole divided by R1 plus R2 plus R3 plus R4. Manas, thank you, beta. Thank you. So R1 is 50. Okay. R2 is 10. Done. R3 is 25 and R4 is 5. So you can write 50 plus 10 plus 25 plus 5. So you can write 50 plus 10 is 60, then 30 divided by 50, 60, 70, 80, 90. It is 90, right? 0 0 cancel out. 3 1 is 3, 3 3 are 9. 3 1 through 3 2 is 6. It is 20, I guess. So my R equivalent came out to be 20 ohm. So R equivalent is 20 ohm. R equivalent is 20 ohm. So this is how you need to get this answer. Okay. Am I lagging? It doesn't show, no? Okay. Okay, one more. And this one would be tricky now. One more, and this would be tricky now. Pay attention to this one now. So let's suppose our values are R. Each resistor is value of R. Okay. And if this one side is A, this point is B, this one is C, this one is D. First part, find resistance across AB. Second part, find resistance across BD. I need answer in these two cases. We need to get the answer in these two cases. Look, I need the answer across RAB. So therefore, this is my first point and this one would be my second point. Done? First point and second point. So you can see now. You can see what, sir? Is it, if we are doing about AB, is it balanced Wheatstone bridge? If I am doing across AB, does it show a Wheatstone bridge? Huh? Yes. So RAB means that it is a balanced condition. It is a balanced Wheatstone bridge. So resistance across AB is equals to R only. But if we are talking about BD, this B and D, okay? So I can make it like this now. Look, R plus R to R plus R is to R plus R is to R. So you can see 2R, 2R and R, these are in parallel, right? So you can write what? Sir, R1 by R equivalent equals to 1 divided by 2R plus 1 divided by R plus 1 divided by 2R. Done. So I can take 1 by R common. It is half plus 1. So I can write 1 by R. Half plus half is 1. It is 1 plus 1 is 2. So I can write 2 by R. So therefore my R equivalent came out to be R by 2. So my R equivalent came out to be R by 2. Easy? Easy now? Easy or very easy? Super easy, no? So you need to guess, no? You need to guess where we need to find our answers. Now I will be giving you some different thing now. Hmm? Now we'll do different now. 1 second. Okay, look now. Okay, value is RR. So we need to find out R equivalent. How we can get it? Look better. If we talk about this one, this one, this one, this one, and this one, it shows you what? It is a balanced Wheatstone bridge. It is what? A balanced Wheatstone bridge. a balanced weight stone bridge. So there is no usage of this one. I will make it, I will redraw the structure. It will be look like this now. Then we have, okay, R. Look, it is R plus 2R, 2R. This one is R. So what will be R equivalent now? 1 by 2R plus 1 by 2R plus 1 by R. I guess my R equivalent came out to be R by 2. This is R by 2 only, no? Okay, one more. One more. So this point is X, this one is Y. All these resistors are having a value of R. How to get it? If you are seeing, yeah, R by 2 is answer, right? If we are seeing it now, we are not getting a single clue that whether it is a balanced or unbalanced case. So how we need to proceed now? We need to tag it, right? If look, let us suppose this is X now, so this would be also X, no potential drop. If this is X, so this will be X, and this will be X, and this will be Y, Y, Y. If let us suppose X, Y, this is Z now, so this will be Z, 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 and X, Y, Z, and this will be, let us suppose, W, 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 and here, right? So how many we have? We have X, Y, Z, and W. So here we have X point. Done. Here we have Y point. Then we have W, X, Y, and Z. Look, this one is between X and Y. This one is between X and Y. So I will make it X and Y. X and Y. Done. This one between, done, X and W. X and W. This one W and Y. W and Y. Okay, this one. Okay. W and Z. W and Z. Z and Y. Z and Y. X and Z. X and Z. All are X. Sorry, R. Okay. I guess now you can see it, no? Sir, it is a clear case of a Wheatstone bridge. This one is a clear case of Wheatstone bridge. And there is no usage of writing this one now. So can I write it like this now? Okay. I will write it like how, sir? Look now. Look. R plus R is 2R. This is 2R. R plus R is 2R. 2R. Then what we have? We have R here. R. So what will be answer now? What will be answer now? Sir, 1 plus 2R plus 1 plus 2R plus 1 by R. So my R equivalent came out to be R by 2. I'm not. Let's suppose that is here, no? No issue. Okay. Okay, if not there, I can write here also, right? This is my battery here. No usage of it, no? Done? Easy or super easy? Huh? I guess you are writing it, no? The battery arm. Yeah, it's easy. Now, look, we discussed how to solve a balanced Wheatstone bridge, and it is very easy. It is very easy. We need to firstly check whether P by Q or R1 by R2 equals to R3 by R4. Is it valid? If yes, then we need to take the middle arm outside. Why? Because there is no current flow through this one. If there is no current flow through this arm, so there is no participation of the resistor in my R equivalent. So I need to take this resistor out. Now, if we have, okay, if we have now unbalanced, I guess in most cases you don't have the idea regarding unbalanced now. Unbalanced. It is unbalanced Wheatstone bridge. Unbalanced Wheatstone bridge. Okay, there are multiple, but there are. If you want some more numericals based on the balanced, you can tell me. I will show you here, right? If not, then we will start the unbalanced now. If you want, you can tell me now. No, beta. There are a lot of things that you need to learn to solve unbalanced now. If you want more cases on balanced, you can just tell me now. If not, then we will start the balanced. Oh, sorry, unbalanced. Okay, what I can do now for the time being, at the end I will be giving you the homework. Okay, I will give you the homework so that you will put some extra efforts from your end. Okay, unbalanced. Unbalanced simply means that, look now, if we are having something like this, R1, R2, R3, R4 and R5. If R1 by R2 equals to R3 by R4, so you can write it as a balanced Wheatstone bridge. Okay, balanced Wheatstone bridge, and current through middle arm equals to 0. But if R1 by R2 is not equals to R3 by R4, you will call it as a unbalanced Wheatstone bridge, and current through middle arm is not equals to 0 now. Is not equals to 0. Now, if, first case here, if now R1 by R2, if it is more than R3 by R4, if the upper ratio of the resistors is more than lower ratio resistors, if this point is B, suppose, and this point is D, so you can write then potential at B will be less than potential at D. So what is the usage of writing VB is less than VD? Hello beta. What is the fun of writing VB is less than VD? I guess if you recall the previous classes, main thing regarding the flow, the current will flow through all the branches R1, R2, R3, R4. But if we are talking about the specifically R5, the middle one, the direction of current gets decided by the ratio. Okay, if R1 by R2 is more than R3 by R4, so which indicates that my potential of B will be less than potential of D. Done? So It simply indicates what, sir? My current will flow from like this. This is my current I. This is my current I. Clear? Then now, or second one, or if R1 R2, if R1 by R2 is less than R3 by R4, in this case, VB potential is more than VD potential, and current will flow from what? 1 second, beta. Current will flow from B to D in this case. In second case. Clear? Now let us do some numericals by which you will get a very clear idea, sir, how to apply the formula and how to get the numericals done. Okay, look now. We have a numerical from NEET PYQ. We will do a numerical from NEET. It is a NEET PYQ. And it shows that we have a something structure like this. We have a structure like this, no? And here we have a galvanometer. Simple. Galvanometer means device which gives you the direction of current. Okay, simple, no? Galvanometer is a device which gives the presence of the current and direction of current. Look now. This one is my circuit. If resistance of this one is 4 ohm, this one is 4 ohm, this one is 1 ohm, this one is 3 ohm. This point is B, this point is G. Now comment on this particular figure. Comment on it. So you can clearly see that, sir, we have labeled it as R1. This one is R2. This one R3. This one R4. So you can see that R1 by R2 is equals to 4 by 4. That is 1:1. No? And R3 by R4 equals to 1 by 3. That is, it is 1:3. So you can see that R1 by R2 is not equals to, it is R3 by R4. So this is a pure case of unbalanced. Okay. So you can see one more thing, that is, sir, R1 by R2. R1 by R2. Is it more than R3 by R4? It's more than, no? 1 is more than 0.33. Okay. Now, therefore, current through this galvanometer is not equals to 0. And current will flow from where to where? I guess current will flow from D to B. Current will flow from D to B. Yes, you are correct. Perfect. This number, look, by doing this one now, you got an idea. By doing this one, you got an idea. Idea of what? Idea of how to label or check whether this particular diagram is balanced or unbalanced. Second thing that we conclude from here, that from wire to wire my current will flow. From wire to wire my current will flow. Then, easy or super easy? I need your response on it. Easy or super easy? Huh? Easy or super easy? Easy? Easy or super easy? Give me your response now. I need your response for easy or super easy thing. Only easy? I guess it is super easy, right, beta? Okay. Now we will deal how to get it done. Look, there are two things. First one is the basics. Second means short trick. Which one you want to learn? Basic or short trick or both? Huh? Okay, what we can do now, I will show you the basics. Look, basic is you need to understand that you need to use short trick only, right? Okay, first of all, we will do a basics. How to find the magnitude of current which will flow from A to B or B to C or C to D. Look now, if we have something like this, look now. Okay, beta. Now I need your full concentration on this diagram. So if this is 2 ohm, this one is 2 ohm. Suppose this one is 1 ohm and this one is 2 ohm. Done. And potential, or this one is X. This could be Y, different potential. This one belongs to V, this is 0. So potential of this side will be 0. Potential of this side is 0. Potential of this side is V. Potential of this side is V. Okay. Okay, done. Clear now? What is R? R equivalent. Is it delta V by I? I guess this one is I, simply. If your battery is giving I, it will take I. If it is giving here I1, I2, so there should be also I1, I2. Done? And here I will get I is equals to I1 plus I2. So here I will have I, and I is equals to I1 plus I2. Yes, current will flow, na? Yes, current will flow through X to Y, na? Or Y to X. I don't know, but current will flow, definitely. And this is 2 ohm also. Suppose current will flow, but I don't know what is the value of current. Okay, so what is delta V? Sir, V minus 0. What is I? Is it I1 plus I2? Okay, V, I1 plus I2. Now, what is I1? I1 is V, this I1, no? I don't take this one, I will take here. If it is I1, so here is I1. So I guess V equals to IR. So I equals to V by R. So V is X minus 0, R is 2. I will write V divided by X by 2 plus same. It is Y minus 0 divided by 2. It will be Y by 2 only. It will be how much? Y by 2. So I will write R equivalent came out to be V divided by X plus Y whole divided by 2, which came out to be 2V by X plus Y. 2V by X plus Y. Remember this one now. Okay. Now what I can do, I will if it is X and Y, so what I can do now, I will place KCL. Write KCL for X1. So here I can write, look, X minus V. Let's go X minus V. So I will write X minus V divided by 2 plus X minus Y divided by 2 plus X minus 0 divided by 2 equals to 0. So I will take, it is X minus V plus X minus Y plus X equals to 0. So X is 3X minus V minus Y equals to 0. I will label it as equation number first. Now I can use KCL for Y also. KCL for Y point also. for y, no? So y is what? Y. So I will write here y minus v by 1 plus y minus x by 2 plus y minus 0 by 2 equals to 0. Done? So I will write y minus v plus y minus x plus y whole divided by 2. It is common, no? So we write 2y minus 2v plus y minus x plus y equals to 0. So it is 3y, 4y. So I will get 4y minus 2v minus x is 0. Equation number second. Equation number second. Look what I can write here, no? Look what I can write here. So it is 4y. Okay. So from this particular diagram, what I can write now? Y. So y is equals to 3x minus v. Place this y in this one. So I will write 4y. Y is 3x minus v minus 2v minus x equals to 0. So it is 12x minus 4v minus 2v minus x equals to 0. It is 12 minus 1. It is 11x minus 6v equals to 0. Then we have 11x equals to 6v. So x came out to be 6v by 11. So what is y now? Y. So y equals to 3. X is 6v by 11 minus v. So y is equals to 18v minus 11v divided by 11. So y equals to 7v by 11. 7v by 11. So what was my R equivalent? R equivalent was 2 times v divided by x plus y. It is 2v. What is x? X is 6v by 11 plus 7v by 11. So I will write 22, no? It is 22v divided by 13. It is v, no? Cancel out. So R equivalent came out to be 22 divided by 13. It is 22 divided by 13. Okay. So if we need this value, so it is equals to 1.692, something like this. My value came out to be 1.6923. You don't need to learn it, no? Because you told me, sir, you need some basics also. That's why I showed it. Okay. But there is short trick also. If you want this thing, now look, we don't have this much of time in examinations. So for examination, we need some short tricks. Okay. We need some short tricks. So how to get it now, short trick? Look now. Look. How to get my short trick. Okay. It is 2 2 1 2 2 2 2 1 2. So I can make it is for short trick now. For short trick. 2 2 2 1 2. One more time I need to write it. Okay. So what I can do now, I need to take this thing out. In first case, join these two. Second case, you need to take it open. Now find R equivalent in this case. Look, these two are in parallel. These two are in parallel. So what will be the value of this one? Sir, it will be 2 into 1 divided by 2 plus 1. And this one R equivalent will be 2 into 2 divided by 2 plus 2. That is 4 by 4. It is 1 ohm only. And it is how much? 2 divided by 3 ohm only. Now I need to add both. So y R equivalent came out to be 2 by 3 plus 1. It will be 5 by 3 ohm only. 5 by 3 ohm only, right? This one, look, these two are in series, so R equivalent will be how much? 4. These two are in series, R equivalent will be how much? 3. Now this one and this one will be in parallel, so R equivalent came out to be 4 into 3 divided by 4 plus 3, 12, 7. Now look, what is the value of 5 by 3? Sir, it is how much? 1.666 something. What is value of 12 by 7? Sir, it is value is 1.71 something, no? So the original value, the real R equivalent will be less than 1.71 and more than 1.66. So you will get only one value. You will get only one value from 4 values in your NEET, no? And you need to click on it. Look here. Sir, basically my real value was 1.692. I guess 1.692, 1.69. It is between 1.71 and 1.66. Easy, no? I guess you can relate this case with the infinite ladder case. Previously, we had discussed the infinite ladder one, no? Okay, because in the look, if we are talking about the examination, no? Yeah, it is good that we know the basics. It is very good that we know the basics, and it is very helpful for our knowledge. If sometimes this formula stuck, so we need to go from the basics, but that will take 3 to 4 minutes. Okay, in respect to my basic now, if we have the shortcut also, I think the shortcut will take mostly 1 minute. So in 1 minute, you will get our answer, no? Okay, I guess you are good, no? Then any issue? Easy or super easy? Is this easy or super easy? Take your time, take your time. I am here, now take your time. There is no need to be in a rush, right? No need to be in a rush. So we'll take 2 minutes break, right? So what is time now? Time is 1:35. We'll be back in 1:40. I will take 4-5 minutes break. I need to drink water. Okay, break. So let us continue today's session now. Okay, so we are done with the resistors part, KVL and KCL. Now let us continue with cell. Okay, so new topic is cell. Cell. New topic is cell. Okay. Do you know what is cell? Do you have any idea about what cell is? Huh? What is cell now? Any idea? Cell basically gives the energy. Okay. Cell gives energy. To whom? To charges. So here we are talking about the electrons, or it maintains. Okay, in your books you will find it maintains potential difference. Okay. Look now, if I will give examples, look here. Something like this, no? Okay. So you will find now, electron will leave this particular place. Now electron will flow in this way. Electron will flow in this way. Okay. What will happen now? What will happen now? Look, this resistor now, it consumes energy. It consumes energy. Let's suppose what is resistor? What is basically a resistor? It is, let us say, fan. It is your fan, your AC, your charger. It needs some energy. Okay, look, your resistor means it should be a fan or AC or charger or whatsoever electrical appliance, right? It needs some energy. It needs some energy. So here, my electron with full energy. It is with full energy. So now it is flowing. These electrons are flowing. Now you can see here, these are flowing. Now when these electrons will reach this resistor, now resistor consumes energy. Now electron will leave here without energy, a minute energy. And now electron will come back to what? To here. Now this battery will charge it again up to this particular point to this one now. And the same thing will continue. So here the battery work is to give energy to your charge. Battery gives energy to your charges, then your charge will take energy and go back to the complete circuit, and resistor will consume it. The electron will come back to the battery again charge it, electron will go consume energy and come back. So this loop continues. This loop continues. It is a basic of definition of all these things, right? Then look now, we know one thing. Sir, what? We know that charge flow from high potential to low potential. Charge flows from high potential to low potential. We know this thing very clearly. This one we know now. The charge flow from high to low potential. We know it. But if we talk about electron, electron flow from low potential to high potential. Electron flow from low to high potential. That means, look, this particular point is low potential. This is plus, it is high potential. So from low to high, electron will flow. But if we zoom here, now if we zoom here, right? Now here, a pile of electron collective gas here, right? These are my electrons, high potential. I need to take the electron from high to low potential. I need to drag these electrons from high to low potential. That means there should be a work done also. I am just conducting electrostatic here. Look, if here is a charged particle Q, I need the charged particle from this to this point now. So I need to drag it, so that I need to put a work done. Okay, in taking the charged particle from this particular point to this particular point. Done? Done now? Yes, sir. One second. So here, could you just tell me? So here, what we have here now? So here you can clearly see now. So my electron needs to go from high potential to low potential. My electron needs to go from high to low potential. Clear? So can I write now, sir? Battery will do external work. Sir, the battery work done by your battery. So your battery is doing work. Your battery is doing work to take your what? To take your electron from high to low potential. What we know now? Look better. Look now here. I guess we know that if we are having plus charge and minus charge, there will be electric field. There will be electric field from positive to negative. We know it. And if here is minus electron, electron will feel force in the opposite direction of electric field. It is force. It will be minus EE. If I need this electron from this particular point to here, I need to apply some what? Force. I need to apply some force. This force will displace it. There will be a work done. There will be a work done. And this work done, and your battery is giving this work done. Your battery is giving this work done. So what you can see now, sir, work done in taking charge particle from high to low potential divided by your charge particle is what? Is delta V, change in electrical potential. Change in electrical potential. Or if potential here is V, here is 0, I can write V minus 0 is W by Q. So V is W by Q. We know it from electrostatic. Here is also. And here is work done by battery only. There is work done by battery only. It is volt, no? But look, if a battery is now look here, now look here, look here. It is very interesting thing. If a battery, suppose if your battery is giving, let's suppose 12 joule, suppose the energy. If your battery is exerting 12 joule, if your battery is exerting 12 joule, how much 12 joule? So I guess this energy gets utilized in two ways. Okay, sir, one part of this energy gets utilized to overcome force. Which force, sir? Minus E. Look, my charge particle is here. I need to take the charge particle to positive to negative end. No? First part. Firstly, I need to overcome this particular force. This is what? This particular force is what? Opposition. This particular force is opposition, and this opposition is known as what? Internal resistance. This one is internal resistance. You will get now feel of what internal resistance is all about. This opposition that your internal electrolytes, internal battery is giving to your electron going from high to low potential, this opposition known internal resistance. And if your battery is exerting 12 joule, let us suppose in 12 joule, 2 joule energy is getting exhausted while overcoming this opposition, then your electron will be with how much? 10 joule energy. So this 12 joule means it is EMF. It is what? EMF. 12 joule is internal resistance or R. 10 joule is potential difference V. Simple example will all the kind of things, right? Easy? So you will get the idea what is internal resistance, what is V, what is EMF. EMF and V both are same. Clear? These are basics that you need to remember. Basic thing. It is very basic thing. I guess you understood it now. Very easy now. I don't think it is very difficult to you, no? But I know a lot of students doesn't know the basics of what internal resistance is all about, what is EMF, what is V, all of these things, right? Done. Okay, now let us represent now battery. We were talking about now. Look, we are talking about, sir, this is my battery with V. Now, as you know that this is not a correct representation of the battery. Why? Because we have not, we have not clearly shown the internal resistance. So we can show it like this now. Look, this is my battery with EMF E and internal resistance R. Combinedly, we are called it as what? My battery or cell. This dotted line, inside the dotted line, we call it a cell or a battery. Done. Once again, beta, good wife. Once again, which portion? Which portion you want again me to repeat? Couple of times I will repeat these terms, no? Automatically you will get these things done. Couple of times I will repeat it. Okay. Look now. Suppose if I know everyone is very good with mechanics now. If this is my sort of box, right? With mass M, I am applying some force F. So what is the usage of this force? First one, force get utilized in two ways. First one, overcome friction. Second one, it will accelerate your box. Okay. First one, it will overcome your friction. When friction gets overcome, then your this box gets accelerated. So your force gets into two ways. In the same way, let us suppose, look here, it is my positive terminal, it's my negative. So we have electric field. We have electric field like this. Okay, this is my electron. We know that in electron, electric field applies force in opposite direction. But I need to get my electron from one to the second portion. So my battery will apply some force. That means work done. Okay, this work done or this force. Okay, first thing, it needs to overcome this one. If this one gets overcome, then only your electron will go to second point. So first of all, it need to overcome this force, this kind of friction, this kind of opposition. This opposition means internal resistance. This opposition means internal resistance. Done? Look now. This particular thing is representation. It is a representation of your cell. Then how to find current now? Look now. How to find current? Suppose we have a battery like structure like this or a cell, no? Then we have a capital R means external resistance. This one is external resistance. E means EMF, R means internal resistance. Internal resistance. Now, if your battery is giving I current, I should be get inside your battery also. So this one is your battery, no? Or your cell. These dotted lines. Clear? You can see here now. Look, we can go like this, and we will apply KVL. Okay. Now look, current is flowing in this way, and we are going along the current. I guess my sign will be negative. Yes, sir. Can I write here? It is minus IR. Current will go inside in this way, and we are going in the same direction. I will write minus I small r. We are going from negative to positive. I need to write plus E equals to 0. So E is equals to I R plus R. So my current came out to be EMF divided by resistance R plus R. This formula you need to learn, that current is equals to EMF divided by resistance summation. Done? Any doubts? Then you can ask me now. If not, then look now. So this is relation of current with EMF. So if I need to manipulate and I need to get my potential difference V or terminal potential difference, how I need to get it? Look beta. Suppose this point is B, this point is A. Again, I will write KVL for a straight line. Okay. Yesterday we done a case now for a straight line. That initial potential plus minus all potential differences equals to the potential difference of the last one. Okay. I will write VB, then minus IR, then plus E equals to VA. Equals to VA. Done? So what will be VA minus VB? Is it E minus IR? So delta V is E minus IR. So this one is the relation of your potential with your EMF. Either super easy. Either super easy. Okay, I will merge these two equations now. This one and this one. I need to merge it. So what is delta V? Sir, delta V equals to E minus IR. And delta V equals to IR. Delta V, what is I? Say I is E divided by R plus R into R. Done? So look now. So can I write now? So delta V equals to ER. I will take R common. One second. One second. So, okay. So, yeah. So I will take this one now. So delta V, it will be E times R divided by, I will take R common. It will be 1 plus R by R. R cancel out. So my major equation is delta V equals to E divided by 1 plus R by R. You need to remember this one also. Okay. Why? Because if you want a graphical manipulation, graph, if you want to write a graph, okay, between V and R, between V and R, look now, I will make a graph R and V. How I will get it? Sir, we know that V is equals to E divided by 1 plus R by R. Okay, initially, case A, initially means if my resistance is 0. What will happen? I will write V equals to E divided by 1 plus R by 0. Something by 0 is infinite. I will write E divided by 1 plus infinite. It is E divided by infinite. Something by infinite is 0. It indicates that when R is 0, V is 0. That simply indicates when E is 0, R is 0 is this point. Then, second point, if R is infinite, so V equals to E divided by 1 plus R by infinite. R by infinite is how much? 0. I will write E divided by 1 plus 0, which is E only. If we are taking R infinite, my value is maximum E. So my graph will look like this now. Okay, it is what? Infinite graph. E value. Done now? Easy or super easy? Easy or super easy? So we are drawing a graph between potential difference or terminal potential difference, the resistance. If we are changing the resistance, if my resistance is 0, my E will be 0. If my resistance is infinite, my V will be E. Okay, last case we will define, then we will just end the class, right? Last case. Case number second, graph between my current and potential, I and V. Okay, okay. So how to get my V and I? How to get my V and I? We know that, sir, V equals to E minus IR. Or I can write it V equals to minus IR plus E. So Y equals to MX plus C. Okay, I can do one thing I can do now. I will rearrange the equation once again. I will write it V equals to minus RI plus E. Now I will just write straight line equation Y equals to MX plus C. My intercept is C. That means this is my intercept is C. Okay, and it should be equals to E. So this value is E here. Y-axis we have V. Y-axis we have V. X-axis we have I. X-axis we have I. So my slope is minus I. Minus I means my theta will be more than 90 degree. Okay, it is straight line. It will be like this. Theta is more than 90 degree. And my slope is how much? R. Resistance R. It is what? A resistance R. Done? An issue now? I guess there shouldn't be any kind of issue now, beta? Huh? Okay, I guess we have discussed a large number of things in this class. Now, rest things we will discuss in tomorrow's class. I hope you enjoyed today's session. If you have any doubts or if you want any suggestion from your end, what you can do, you can just comment to my videos, and also that you can just go to the channel description part. You will find my Telegram channel. You can join Telegram channel and you will get notes there, mind maps, notes. You will get the homework question there also. And if you want connecting with me directly, you will find my Telegram username also there, right? So you can just connect with me for your mentorship or all these kind of things. But for that, you need to go to channel description part and you will get my Telegram link. Or you can write Shakoor sir physics also, and you will get the Telegram channel. Okay. So I hope that you got something new in this class, and I hope all the best. Thank you and good night. Bye, beta. Thank you, beta. Bye. Bye. Good night, beta.